Web developers are often required to create applications that are responsive as well as media-rich. Working with image breakpoints and media queries, we can provide the best experience to the end users. In this video, I'm going to show you how to use Angular's breakpoint observer, together with Cloudinary's transformations, to implement art-directed responsive images. The art direction challenge is adjusting images for different screen sizes. For example, a desktop view may show a wide landscape with a person centered, but on mobile, shrinking the same image makes the person too small. A better approach would be to use a portrait version on mobile that zooms in on the person. Angular's breakpoint observer allows you to detect viewport changes dynamically, enabling component behaviors, layouts, and styles to adapt based on screen width. Instead of relying solely on CSS media queries, this service gives Angular applications programmatic control over breakpoints. To use the breakpoint observer, we need to install Angular's CDK layout module, which we can do via npm. In your terminal, type npm i Angular CDK. Then, in your Angular app component, import breakpoint observer and breakpoints from Angular CDK layout. Inside the app component, let's define variables that will store the image URL and the current breakpoint. We'll also set the base URL variable to the image we want to deliver from Cloudinary. It's a picture of a man playing a guitar, which I already uploaded to my Cloudinary product environment. Next, we need to set up a dictionary that maps predefined Angular breakpoints to different Cloudinary transformation strings. As this is art-directive responsiveness, you can set different transformations for each breakpoint. For example, when the viewport is large, you may want to display a banner-type image with aspect ratio 2:1. Using automatic cropping, C-auto, with automatic gravity, G-auto, you can ensure that you keep the most important parts of the image in the crop. You can differentiate between large and extra large by changing the width parameter. This ensures the image is optimized to the right size before being delivered, saving bandwidth. So for large, we'll set it to 800 pixels, and for extra large, we'll set it to 1200 pixels. For the smaller images, perhaps you want a close-up of the person's face, so you could use the thumbnail crop with face as the gravity. Next, use dependency injection in the constructor to inject breakpoint observer. This allows us to detect screen size changes. Inside ng-on-init, we use breakpoint observer to monitor viewport changes. The object.keys code extracts breakpoint keys from the Cloudinary transformations dictionary, and the observe function monitors these breakpoints. The subscribe function listens for breakpoint changes, so this code runs if the screen size changes. It iterates through result.breakpoints to find the active one, then updates this .breakpoint and this .image path accordingly. getCloudinary URL is a helper function that modifies the Cloudinary image URL by injecting the correct transformation. It splits the image URL into parts based on forward slashes and finds the right place to insert the transformation string, just after the upload component. So now, in our HTML, we can display the image using a simple image tag with the source set to the generated image path. If we run our app, we can see that when the screen size is large, we get the banner image, and as we reduce the size, we see new images being requested. Different parts of the image are displayed based on the transformations that we specified in the code. At the smallest size, we see a close-up of his face. So now you have full control over your responsive images, with different variations being generated by Cloudinary on the fly. Next up, learn how to install and configure the Cloudinary Angular SDK for programmatic transformation building.